All right, we are going to be solving equations with squares and square roots. Okay, now here's what we need to know. Squaring a number, and square rooting a number, these are inverse operations. They are inverse operations the same way that adding and subtracting are inverse operations. So here, for example, if I want to get x by itself, I need to do the inverse operation, right? Like let's say, for example, I have x plus 3. I would do, oh, what's happening to x? 3 is being added, so let me subtract 3. Right? And this is how I would solve the equation. These are inverse operations, okay? So in this case, I have the square root of x, so I'm going to do the inverse of square root. The inverse of square root is squared, okay? Now, for the sake of your notes, I want you to recopy this. Like, look, literally, I'm recopying exactly this, so you can kind of see the steps. But in the future, if you get an equation like this, you don't need to copy it. But look, what I'm going to do is I'm going to take this square root, and I'm going to say, you know what? The inverse of square root is squared. Now look, right here, I saw, oh, there's addition, I'm going to subtract. And what did I have to do? If I did it on one side, I have to do it on the other side. So here, I'm squaring. And so if I square it on this side, I have to square on this side. So I get x equals 9 squared is 9 times 9 is 81. Okay, I'm done. Look, you could also look at this and say, the square root of what number is 9? Oh, the square root of 81 is 9. So this is done. Okay, let's take a look at this next one. I have x squared equals 16. Some number multiplied by itself equals 16. So you might be thinking to yourself, it's 4. And you'd be half right, okay? Careful. So look, again, just for the sake of examples, I'm going to recopy. I have squared. So when I see squared, I'm going to say, oh, let me do the inverse. I'm going to square root. If I square it on one side, I have to square it on the other side. Okay, now, here's where things get tricky. Look, just like here, look, squared and square root, those cancel. Those are inverses. I'm left with just x. Same here, square and square root, those cancel. I'm left with just x. The square root of 16, however, this is where it gets tricky. The square root of 16 is 4. However, look, 4 times 4 equals 16. But there's another number that if I multiply it by itself, it also equals 16. And that other number is negative 4. So negative 4 times negative 4 is also 16, right? So the answer here is actually negative 4 or positive 4, okay? X could be negative 4. It could be positive 4, right? Let's look at this one. Some number squared equals negative 25. Now, you could think to yourself, okay, I have x squared. I'm going to square root. Here's the thing. There is no number that you could multiply by itself and get negative 25. Because look, let's say it was 5. 5 times 5? What's 5 times 5? That's positive 25. What if it was negative 5? Negative 5 times negative 5, that equals also positive 25. So this, we do have a way of square rooting negatives in Algebra 2, okay? In Algebra 2, it's called an imaginary number, okay? And it's like this. It's the square root of negative 1. It's considered an imaginary number. It's not a real number. It's something you're going to learn more about in Algebra 2, but for right now, what we write is no real solutions. Okay, you just literally will write that, no real solutions, okay? So notice what's tricky about this is there's some possibilities. This one has one solution. Okay, when I just square a number, it's just, oh, 9 times 9, it's 81. That's one solution. This one has two solutions. And this one has no real solutions, okay? So this is kind of tricky.